The people on the project and the trypanosomiasis project, they produce the data, so they directly interact with the cows and the cattle in Africa, and then we have researchers at Liverpool who analyse the data in the chromosome regions associated with a particular disease. Now, they're not necessarily data consumers, so they're data providers, like you say. So the data consumers are the end users. So I construct data analysis workflows using sort of distributed services and data sets. And I come up with a list of hypotheses which I can then provide the data consumers or the end biologists with a series of hypotheses to go and do some investigations at the end. And they go and do those in the laboratory or refine some methods based on those back in ILRI or whatever. The methods that I build are species specific, so I build a method for a mouse, and I build one for a human and one for a cow. So the cow one is only built for the cow and the mouse only for the mouse. But I can just change a particular service, and then that would enable me to analyse a new species, and that's just one service, so it's quickly to do that. So the kind of projects I've been working with now, so I built the mouse one specific for analysing chromosome regions for this trypanosomiasis project. But I've been outreaching to various people in different life science departments, and I've now been working with epilepsy data. I've been working with inflammatory bowel disease and colitis, apoptotic dermatitis, I hope I said that right, and also with human, we're now looking at, again, epilepsy, so we've transferred it from the mouse to the human, so we can see comparisons there, and also looking at blood pressure in the human as well. It's basically building an infrastructure which is, in essence, species independent, but the underlying methodology should be the same. So they provide me some data, I analyse it and give them some hypotheses which they can go and test in the laboratory afterwards. The complexity of the data is a problem in that we have multiple chromosome regions that are linked to one disease, and that is resistance or tolerance to trypanosomiasis. So the idea is that we've got 3 QTL regions. Now, each of those regions has several hundred genes in them, and to analyse those independently and in an unbiased manner and a systematic manner takes a lot of time and effort. So I developed, along with some researchers on the Taverna project, an infrastructure which provides a methodology for taking all of those genes, processing them simultaneously and coming up with a list of annotations, and that's done systematically in an unbiased manner. We can see exactly what services and what processes we've used, how the data was transformed and manipulated, how it's stored, and again, with the species dependency, we can then say, okay, this particular service is related to the mouse or the cow. We can take that out. The rest of the thing stays the same, so the time methodology stays the same. Put the new human one in, connect the ports up and things, and then it works exactly the same. So we can just quickly change services rather than going through and reanalysing all this data through different web pages and so on. So it would take, normally, I'd say, we've had an estimate from someone in life science for looking at trichuris disease, and it took them 2 years to find something that took me 45 minutes. So it's a big saving of time and effort, really, to analyse this data. So I've created a series of workflows that analyse previous existing literature and mine those publications for possible correlations between hypotheses that are generated using these workflows and what's already known. So there's information that's already locked in publications, but it's how to get that information out. It always needs a person to use their keen sort of eye and their biological knowledge to skim over results. But we can assist in hypothesis generation using these workflows and data infrastructure.